This lecture introduces Chapter 7, Atmospheres of Venus, Earth, and Mars. An atmosphere is a layer of gases surrounding a planet or other material body, that is held in place by the gravity of that body. The term stellar atmosphere describes the outer layers of a star from the opaque photosphere outwards. This learning module discusses the origin, structure, and composition of planetary atmospheres. The learning goals of this learning module are, to be able to define the layers of atmospheres for Earth, Venus, and Mars, and explain the existence of these layers, explain the origins of and differences of primary and secondary atmospheres, compare the strength of the greenhouse effect and differences in atmospheres of Earth, Venus, and Mars, describe how Earth's atmosphere composition has been reshaped by life, and describe the evidence that shows Earth's climate is changing. In the introduction to Chapter 5, we talked about pressure, temperature, and density. Since these measurements characterize gases, they are important for describing atmospheres and understanding how they form and evolve. Chemical composition of an atmosphere varies as a function of altitude just as pressure, temperature, and density. Earth's atmosphere is about 78% nitrogen, 20% oxygen, and a mixture of other gases collectively called the minor species. Although their partial pressures are small, the greenhouse gases such as carbon dioxide and methane influence the temperature of the planet. Life is possible because of the greenhouse effect. However, anthropogenic sources of greenhouse gases are thought to be contributing to global climate change, making our planet less habitable and causing mass extinctions. A brief timeline of the early history of understanding planetary atmosphere is presented now. Galileo patented a machine that could pump water from a river for the irrigation of land. The heart of the pump was a syringe. Galileo discovered a limit that the water would rise in the suction pump, around 10 meters. He was unable to explain the cause for this limit. Italian physicist Evangelista Torricelli filled a tube 1 meter long, closed at one end, with mercury and set it vertically with the open end in a basin of mercury. The column of mercury invariably fell to about 760 millimeters, leaving an empty space above its level. Torricelli thought it was due to some yet unknown force on the surface of the Earth. Concluding that the space in the top part of the tube was empty, he called this nothing a vacuum. Torricelli had invented the barometer to study the problem of Galileo's pumps, that limit of 10 meters to which fluids could rise. Blaise Pascal, a French philosopher, physicist and mathematician, was intrigued by Torricelli's experiments to explain Galileo's pump. He concluded that the force, which keeps the column at 760 millimeters, is the weight of the air above. He reasoned that on a mountain, the force must be reduced by the weight of the air between the valley and the mountain, and predicted that the height of the column would decrease as the barometer is placed at higher altitudes. In 1648 Pascal and his friend and colleague Florent Perrier hiked up the Puy de Dôme, a small grass-covered extinct volcano in central France with a summit elevation of 1,464 meters. They carried a Torricelli barometer with them. The mercury level in the glass column was lower than it was at lower elevations. They concluded that the differences in height of the mercury were caused by differences in the weight of air above. From the decrease he could calculate the weight of the air. Based on this finding, Pascal concluded that a vacuum exists above the atmosphere. Pascal called the force pressure and further deduced that it acts uniformly in all directions. Otto von Guericke, German scientist and inventor, invented a pump that created a vacuum holding together two metal hemispheres so strongly that a team of 16 horses could not pull them apart. Otto von Guericke reasoned that the hemispheres were held together by the mechanical force of the atmosphere's pressure. Dutch mathematician and scientist, Christian Huygens invented the manometer, a U-shaped tube where the ends are exposed to different atmosphere pressures and the difference in fluid height of a liquid in the tube is proportional to the difference in those pressures. He used it to study the elastic forces in gases. Robert Boyle, an Anglo-Irish chemist, used J-shaped tubes closed at one end to study the relationship between the pressure and volume of a gas. He found Boyle's law that states that the product of pressure and volume is a constant, provided that neither the temperature nor the amount of gas is changed.
In a demonstration of Boyle's law, we'll place a balloon in a vacuum bell jar. We'll apply a vacuum which basically pumps out the air in the bell jar. The pressure outside the balloon will be greater than the pressure inside. The balloon expands to try and equalize the pressure. Volume and pressure are inversely related to each other. When we release the vacuum, the pressure increases and the volume decreases. As another demonstration of Boyle's law, we will put a marshmallow peep into our vacuum jar. The marshmallow contains air trapped in a mixture of gelatin and sugar. As we apply the vacuum, the pressure outside is lower than the pressure inside. The air in the peep will expand to try and equalize the pressure. When we release the vacuum, the pressure increases and the volume decreases. As another illustration of Boyle's law, we will put some shaving cream into our vacuum jar. The shaving cream contains air trapped in a soap mixture. As we apply a vacuum, the pressure outside is lower than the pressure inside. The shaving cream will expand to try and equalize the pressure. As you decrease the pressure, the volume increases.
This is a demonstration of Boyle's law.
Jacques-Charles' experiments showed that when the pressure on a sample of a dry gas is held constant, the Kelvin temperature and the volume will be directly related. He also worked on the first hydrogen balloon and some manned balloons. In 1786, explorers climbed the 4,810-meter Mont Blanc. In 1787, Horace Benedict de Saussure climbed to its summit to explore the atmosphere. They found that air temperature decreases with height in the atmosphere by about 0.7 C per 100 meters. John Dalton experimented with gases and developed what is now known as Dalton's law. In a mixture of gases, the total pressure is equal to the sum of the pressure of each gas, as if it were in a container by itself. The pressure exerted by each gas is called its partial pressure. Gay-Lussac discovered the law of combining volumes. If two volumes of hydrogen combined with one volume of oxygen, it would form two volumes of water. Based on Gay-Lussac's experiments, Avogadro hypothesized that the pressure in a container is directly proportional to the number of particles in that container. Example, blowing up a balloon, the more air is added, the larger the balloon becomes due to pressure. Teiser and Debord sent instruments up in balloons that recorded temperature and air pressure. About 200 balloons consistently showed that at a certain height in the atmosphere, temperature no longer dropped, but remained nearly constant 8 and 13 kilometers high in the atmosphere. Assmann invented strong rubber weather balloons which were more durable and reliable than paper or fabric balloons. As the rubber balloons rose, they expanded as the air pressure decreased. At a certain altitude, the rubber could no longer stretch and the balloon would explode, which is why they were called Assmann's expansible and exploding balloons. After the balloon exploded, the instruments were carried to the ground by a little parachute. Assmann flew instruments on his expansible and exploding balloons high in the atmosphere, finding that, not only did air stop cooling at a certain altitude, it started to warm from 10 to 15 kilometers in the atmosphere. He shares the credit of discovering the stratosphere with Debord. Assmann's probes included aspiration psychrometers to measure moist air. As you increase altitude, more atmosphere is below you and less is above you. Therefore, pressure always decreases with increasing height. Often, the vertical height is given by the pressure rather than the physical distance to the ground. Meteorologists reference temperature, moisture, and wind to standard pressure levels. Change of pressure with height can be used to measure altitude of aircraft. In summary, an atmosphere is a layer of gases surrounding a planet or other material body, that is held in place by the gravity of that body. Covering Earth is a thin atmosphere layer. Approximately 80% of the atmosphere occurs in the lowest 20 kilometers above the Earth compared to the 6,378 kilometers radius of the planet. Pressure, by definition and laws of physics, must decrease with decreasing altitude.